Welcome to episode 83. It's our fourth standalone episode of the G2 on 5G. It's brought to you by More Insights and Strategy. And today, Anshel and I welcome Juan Montojo. He's the VP of Technical Standards with Qualcomm, and we're going to discuss 3GPP Release 18. Juan, welcome to the podcast.
Thank you very much. Happy to be here.
Awesome. I'm going to start with the first question.
All right.
Can you talk about the major enhancements that Release 18 could bring to 5G over what we've seen in 15, 16, and 17?
Sure. Actually, unlike other releases, and certainly releases preceding the 5G release preceding this one, Release 18, there is a good mix of new areas and notable continuations. So actually, it is typically the case whenever a new generation of wireless comes in, there is actually a whole a bunch of new functionality and features that come with that release. And then actually we saw that in Release 15, the original release of NR. And now with Release 18, which is the first release of a 5G Advanced, as we call it, it brings in a very good balance of basically these more new areas as well as these continuations. So just to name a few, we will have plenty of work on AI ML, so artificial intelligence, machine learning applied to the air interface, also applied to the NG-RAN, to the next generation radio access network. Also, we will have a study on full duplex. It's called enhanced duplexing operation. A new project on network energy savings. This is something new, and 3GPP had not done so far for 5G. And then some other areas to name a few more: low power wake up. There is also, we are tapping on XR, we are tapping on drones, and we are actually enabling operation of NR for dedicated spectrum with allocations of less than 5 megahertz. There are other continuation areas like, of course, MIMO and coverage. Those are very, very important to network operators. There are good continuations on positioning, sidelink, satellites, reduced capability, further reducing, or actually aiming at further reducing the capability required for NR devices. And I'm sure in the sequel we will get into more details on some of these.
Great stuff, Anshel. I'll let you ask the next question.
All right.
Yeah, there's a lot to go on. I guess one of the questions I had, and since you mentioned so many of the new areas, I was kind of curious as to what the expectations are around significant projects looking at improvements in performance specifically. Mm-hmm. I heard you mention MIMO, but yep. What other performance improvements are expected with Release 18?
So it's actually a good point. What I wanted to say there is that performance is always improved. I mean, what basically changes is what axis, right? Or what dimension is the one that we are trying to improve? Is it basically power consumption? Is it coverage? Is it the spectral efficiency? Or is it even addressing new use cases, right? So this is where actually I believe this package that was approved last December brings in actually a good set, right? I mean, some of them, as you mentioned, MIMO and coverage, basically those two are important, but I think we cannot neglect, for example, the importance of power, the importance of actually even having the 5G networks being tailored to XR type applications. These are the other things that we will see, and then certainly other areas. I mean that we may be able to see exploiting or actually trying to come more into mainstream as some positioning, some sidelink applications, as we will see them being developed in Release 18.
And I guess with the sidelink, I remember you talking about sidelink during the webinar that I tweeted out. What do you see sidelink like? Sidelink has been something that's been talked about a lot. Yeah. Do you see that getting any more traction with Release 18 over previous implementations of sidelink?
It's an excellent point, and I wish I had an answer. I at first sight it seems that it could be the release that may unlock the value of sidelink. The simple reason is sidelink has to be linked to, whether we like it or not, to spectrum, right? It has to operate in a particular spectrum, and then typically the problem is well solved for example, for the automotive use case, where there is this industrial transportation system spectrum, the ITS, which is unlicensed spectrum. Nobody pays for that, but is dedicated for these automotive use cases, and there is IT spectrum effectively available worldwide. But for other type of applications, there is either license, basically MNO own, like mobile network operator own spectrum, or unlicensed. And then for the unlicensed, up to now, there is no side link being defined for 5G or 4G for that matter, right? So this is what one of the main aspects that LTE Advanced and Release 8 in particular will bring in. The availability of actually the tapping on a licensed spectrum for silent communication, which is, for example, something that, not surprisingly, it's already been done by Wi-Fi and Bluetooth competing technologies, right? The question is whether there will be value and appetite to explore these NR-based, 5G NR-based type solutions.
Yeah, and on that topic of utilizing things that may have been underutilized, I was going to ask you about satellite, because Release 17 kind of introduces satellite as a possibility for communications on 5G. But what enhancements does Release 18 bring to satellite in 5G that 17 doesn't have?
Yes. Another very important area, in our opinion, is true satellite is being one of those industries, along with automotive and some others industrial, that 3GPP has been welcoming. Basically, they started the studies on satellite back in really at the beginning of Release 15 work item. It was a study item back then. There were two releases of a study, and then, as you said, Release 17 sees indeed two satellite projects. There is one NTN satellite project, or NTN NR project, and then there is one project for NTN IoT, which actually puts EMTC and narrowband IoT over a satellite link. For both of the projects, basically there are, I would say, improvements for NR satellite. Qualcomm's biggest interest is to try to bring in mainstream, effectively into applications that would enable operation of this satellite system in a plain vanilla smartphone form factor without really the need of an external antenna. So we are fairly confident that we can basically support with Release 17 basic functionality like short messaging. We are not totally certain that we will be able to support voice, and that would be really the main goal for Release 18, right? Bring in the necessary enhancements, and actually I can give you a couple of those examples, areas that actually could enable us to put voice support on satellite. Still, there will be certain restrictions. People will have to be outdoors, of course. People will have maybe to basically have a clear view of the sky just above. But what we would like to do is maybe enable better or improved support of low codec rates. As you know, this voice support is done via codecs. Actually, those have been developed, with lower and lower data rates and still keeping a good level of fidelity, but also trying to solve some of the known issues on talking about MIMO. Some polarization loss is something typically phones or handsets come with, particularly in these frequency regimes, come with vertical, horizontal polarizations, while satellites have circular. So there is a polarization mismatch, which comes accompanied by some loss in link budget, which is actually something that we will really want to recoup. And then there are some improvements on mobility. So this terrestrial to non-terrestrial, non-terrestrial to terrestrial network type mobility. On the IoT NTN, there are some performance enhancements, some things. It was actually a project that was indeed rushed in Release 17. It was meant to be only a study, but we managed, because of the COVID extending the release, we managed to basically get a work item within the same release, but then with minimal changes. And there are some well-identified areas of improvement, like HARC disabling, some enhancements on power consumption due to, for example, GNSS locking. It takes a long time, and potentially, and it could drain, potentially the battery of the device. And then some other similar to the NRNTN and mobility enhancements. So those are the two major areas. Basically link efficiency, trying to improve the link budget, as well as improve mobility support.
Hey, Juan, I've got a couple questions for you, and they really focus
Sure.
on the operator impact. And so, I mean, there's a wealth of new functionality with release 18. We were talking about satellite. I mean, that's huge. But I'm wondering, my first question for you is, does release 18 drive incremental infrastructure requirements for operators, whether that's in, incremental antennas or software? I mean, obviously 5G is inherently more virtualized and software defined than LTE was, but does that drive incremental infrastructure requirements for the
Yes, it's another very important area and definitely an area of concern for operators, right? I mean, they really want to leverage their deployments to the maximum extent. Of course, coverage and MIMO are coverage. MIMO, which is basically the one bringing spectral efficiency and mobility, could be probably the main axis for KPIs of network operators, right? I want to have coverage, I want to have a good user experience, and I want to have that user experience is good data rates and basically no call drops, right? So a lot of it comes with effectively improving how the network gets deployed. With 5G, we are moving up in frequencies, which enable us to put more antennas in the same area. Actually, in FR1, there is this massive MIMO technique. In FR2, with analog beamforming. But of course, those techniques are just getting improved in every release, right? So there is a good deal of actual improvements coming in this release. One area which are particularly important, I think, for operators and infrastructure vendors could be how to bring in the possibility to deploy at a cost-efficient way, right? So in release 16, we introduced integrated access and backhaul. This is a type of, you can think of it of a relay, which enables a wireless backhaul, which actually if you think of it, could actually deploy, is the deployment of actually networks. One could argue that IAB node, which actually has been evolved and actually is going mobile in release 18, it's adding even an available feature up to now. It's still costly. And in that sense, at least Qualcomm is trying to see, what are the other ways that actually operators could tap on to enable these cost-efficient deployments. So areas like repeaters, I mean, we're introducing release 17 for all types of spectrum. Those are basically very basic RF repeaters, I mean, which actually get improved in release 18 with what we call smart repeaters. This is what we've been calling them for a while now. 3GPP decided to change the name to network control repeaters, and basically the name says it all, right? There will be a parent node, basically a G node B that would actually, a base station that will control to enable this selective amplification of the signal when and in the direction that it matters and is needed the most. So we are actually quite excited with that possibility that the repeaters will bring in. And then I think other incremental enhancements could be in the area of XR. I mean, if you want to ask what is the killer app of 5G, still probably there is really no app as of today that has really come in that was not there supported already before in 4G networks, right? So, but I think the big wave of XR has yet to come. And in that sense, this is going to be the first release where we will see radio optimized operation of XR. And XR is AR with glasses. It could be virtual reality with head-mounted displays. And some other types of applications like online gaming, right? And then finally, we talk about infrastructure enhancements. Network energy savings is the other one, right? Where both infrastructure as well as mobile network operators will try to enable the possibility to make the best use of the real estate in that particular platform, right? It's a very complex platform, and what really the goal of the project is to try to intelligently turn off certain components, whether it's in time, in frequency, in dimensions, in space. If you weren't basically turning down particular antenna elements just to save power, for example, and then to lower the energy bill, right, of operators. So those are, I think, the main ones I can think of. More forward-looking, there is the full duplex business, which also would enable new operations. I mean, as you know, it's another new project. It's a study only. We will try to see what we learn out of it. There is a component on dynamic TDD. There is a component on actually enabling this transmission and reception within the same resources, which, if you think, could facilitate the use of TDD spectrum as we have it today, more and more in 5G networks, right? So with that, basically, I think that provided you a good summary of the areas.
Oh, it certainly did. And you touched on XR, and that's a nice segue to my second part of the question. So I spent a lot of time with operators. That's one of the things I've been focused on within our firm, and infrastructure, obviously. But you mentioned XR, but I'm wondering if you were to pick two or three of the enhancements, which do you think have the potential to drive the most monetization for operators?
I think this easy of deployment is a key aspect. I still believe, especially for high frequencies, is going to be very important to try to see what is it that we can enable for operators to be able to have their better, improved offerings without really basically draining their basically capital, right? Sure. I think that. And then operators really care about, I would say, coverage. Coverage, I think, is another one. Within actually the coverage project, there are a couple of actually important aspects, both relate to uplink. I mean, if you think about today's networks, probably the bottlenecks are coming from the uplink. This is the direct, for the terminals being transmitting on the reverse link, right? And those actually relate to, for example, dynamically changing the waveform. So NR was designed from release 15 with two uplink waveforms. One is the same as LTE for uplink, is this DFT spread OFDM, which is only for one layer transmission. So this is non-MIMO transmission. And then for more than one layer transmission, this is MIMO, more than one stream. You change to OFDM, and OFDM is the waveform that has been used since LTE days for the downlink. So in release 15, these waveforms can only be selected semi-statically. So what ends up happening is that to enable MIMO, you have to enable OFDM, right? And to enable OFDM, the operator, typically in infrastructure vendors, will try to play very safe on actually, do I have enough margin, link margin, to basically close the loop with this OFDM waveform, which is actually more demanding in terms of transmit power. And in that sense, we are now introducing dynamic waveform selection, which I believe will certainly help into this uplink MIMO, see more uplink MIMO in actual deployments. That will be one. The other one is uplink carrier aggregation. So carrier aggregation is basically the ability to put multiple chunks of spectrum, basically in a single transmission, to basically linearly increase the data rates, right? So if you have one carrier, you get X. If you have two carriers, you get 2X, right? And so on. Typically is being very successful for the downlink, but for the uplink, because of the way that uplink transmit power gets limited by specifications, we are seeing it uplink carrier aggregation very limited to very self-centered type devices. So if you just happen to be very close to the tower, right, of the base station. And there are a number of areas that actually we're trying to tap on to enable the ability to basically use more carrier aggregation on the uplink as well. We call them dynamic power aggregation. Also, there are some energy efficiency improvements by playing with some spectrum shaping, some maybe tone reservation to enable basically higher spectral efficiency uplink transmissions. So those are two areas that I think will definitely make a dent to today's networks.
Great, great information. I'm going to hand it back to Anshel, and he's going to wrap up with a few remaining questions.
Thank you.
Yeah.
So far, this has been great. I'm enjoying these answers because I don't think we got this kind of detail out of the webinar. But to be fair, it's kind of hard to do that when you've got so much to cover.
That's right. That's right.
I guess one of my last questions is if there are any release 18 items that we should know about that haven't really been talked about in detail that you think are of note that the industry might want to be paying attention to?
I mean, it's a good question. So the package is very rich. We try to give fairness to the projects that actually are more impacting. Of course, there are some, I would say, projects that are more basically, okay, we do this for one additional release. There are, I would say, very few of those. I mean, I think we've been very, very diligent in actually picking a good choice of actually projects. One thing I wanted to say is, well, 3GPP, it's come in different working groups. The air interface is basically 2 working groups, RAN 1, RAN 2, and then the network protocols comes in RAN 3. The package improved, basically entail only those 3. There is another group, it's called RAN 4, which is effectively the one closer to the implementation of devices and networks. And basically the package has to be approved in March. There will be some projects there maybe of importance. I mean, still we will have to see in March. And I believe there is, in the webinar, we made a very brief mention to this passive IoT. That was a project that was brought in. It was brought in late into the discussion, and as such, basically didn't make it to the package. I'm fairly positive that we will see some of it in release 18 with a late approval, maybe over the summer or so. That actually relates to some degree to this wake up, very low power wake up, like some people call it 0 power. But it basically, it generalizes that to the extent of even actual communication without batteries, right? I mean, and it would be actually a new paradigm for 3GPP, which is effectively this traditional base station terminal type system to one system that would be potentially a completely new one. Think of it of an RFID system, right? And then, but yes, at the same time, you would put thousands of minds to think about this problem, right? I mean, which might be of interest. So I think that could be the only one worth mentioning that we've not done, maybe to the extent that the interest may actually deserve.
Yeah, I genuinely found that the idea of passive IoT as part of the 3GPP standard to be very interesting.
Mm-hmm.
And I'm glad that you kind of brought that one up, because it seemed very, to your point, out of the general wheelhouse.
Yeah.
But I think it has potential to improve, massively improve logistics and all kinds of things. So I definitely appreciate you bringing that up.
Yeah.
And I think that kind of wraps things up for us. I wanted to say thank you very much for putting up with our questions and
My pleasure.
answering our queries. We hope our viewers and listeners found this week's topics interesting. If anyone out there would like to provide us with insights on a specific 5G topic for a future podcast, please reach out to us on social media. Will is at Willtown Tech, and I'm at Anshel Saad. And thanks again to Juan and Qualcomm for joining us, and we hope you have a great week.
All right. Thank you all.